Hello, everyone. Glad to be here. It's my second Scalar conference. My name is Vladimir, and I'm really happy to be speaking to you this year again. Today, I'll be talking about event sourcing and specifically about Aecor library, which is a library for writing event-sourced applications in a purely functional way in Scala. It's used extensively in the company I currently work for, which is a Russian company called Aecor. The library was developed there as well by this guy, Denis Mikhailov. He was has been refining these abstractions and the runtime for like more than 2 years, so the library is already quite mature and tested thoroughly in production by our company. So I'll quickly cover the building blocks of the library. The core is called behaviors. It's about writing your domain logic in a maximum expressive, like highly expressive way, without tying it to infrastructure layer. The thing about Andres talked about in his previous talk. So this is just pure domain logic. Then goes the runtime, which is an infrastructure layer. It consists of 3 parts, which is consensus or single writer principle, which is provided by Aecor cluster. Then it's journaling and serialization, the way you store events, the way you restore your entities from journal, and so on. And the last thing is a wire protocol, which is basically the protocol of interaction between the nodes in your cluster. Also, there are components for CQRS to build views or other kind of read-side projections. And distributed processing is a thing that allows you to spread any kind of computation over your cluster, again, in a purely functional way. So recently in Minsk at FBI, I tried to fit everything in one talk, to talk about everything in one talk, and I kind of failed because it's too much. So today I'll take a different approach. I'll be talking just about one concept, but cover it in more detail. So in case someone will be hooked up or is already hooked up, you can check out all the concepts and all the details in this blog post series on my blog. So I invite you to check it out over this simple link if you want to learn everything about Aecor library. But today we are going to talk about behaviors. In short, behavior is a set of actions or verbs that can happen with some kind of domain entity. Aecor is intentionally focused on behaviors and not data because it's kind of at the roots of domain-driven design, which inspired Aecor a lot. So it usually leads to a much better domain models, and we'll see it in example. Let's say we are selling concert tickets. So this is our domain. We would probably have some kind of booking entity which would encapsulate all the logic, all the behaviors that are related to booking. So for example, there would be some kind of life cycle. So booking is placed, then it is confirmed, then it might be paid or expire. So we would usually want to kind of take it all and put it in a single kind of consistent piece of, like a piece of logic, which would be called an entity. So there are still, these days, there are still a lot of people who start designing such things with a question like this, like what data should it store, or even what database schema will it have. This is an approach which worked for a lot of years. It's really old, but these days more and more people are realize that it's not the best question to start with. It's usually a much better design you'll get a much better design if you focus on how should it behave, like what actions does it support, what can I do with it. So we focus on verbs first, not nouns. And there are a lot of advantages to this approach. I won't be discussing them today. Any decent domain-driven design book will outline them to you in a good fashion. So I just wanted to show that Aecor being focused on behaviors is not accidental. It's a explicit design choice. And this approach really shines with event sourcing because comments and events are inherently behavioral. They are verbs. One is present tense, the other is past tense. So here are some simple examples from the same domain. You can place a booking, and if it happens successfully, then the booking is placed, and so on. So if you want to talk about behaviors and you pick event sourcing, this is quite a good fit. So now we're going to talk about behaviors in Aecor specifically, but first I want to pay some respects. So these days still I sometimes play computer games, and when I do this, I usually love playing for undead, this creatures, undead fraction. I don't know, there's some charm in it. They have like this unique style and unique these abilities. Like how would you fight necromancy? They rise more warriors than you kill. So how would you fight that? So for some reason I really love playing these guys, and thanks to John DeGoes, I can now, when I program, I can also take my favorite pick, which is final tagless. It's kind of, apparently it's already dead. So yeah. So let the dead rise and take over Scala world again. And our necromant ritual will start from a simple, not simple, but sample Aecor behavior, which would look like this. So again, ticket bookings. So what can we say about this thing? So first of all, you can see the verbs, which are like place, confirm, deny. These are the verbs of our domain entity. This is our behavior. Notice that so far the code is completely library agnostic. It's not only infrastructure agnostic, it's even library agnostic. So again, the thing that was discussed in the previous presentation, we don't tie our domain logic to infrastructure concerns. And so far, it's even library agnostic. So it's just final tagless algebra. Let's study this thing a bit in detail. So on the left is the same algebra, just a little bit compressed. And on the right is kind of visual representation. So an instance of such algebra would represent a specific instance of an entity. So I put some kind of ID here to kind of show that. So that this would be an interface to a specific entity, some specific booking that was created at some point in time by some user, and the methods on the algebra would represent a way to perform some actions. Yeah, so algebra instance is an entity instance. This thing can actually be interpreted in many ways. You can run it over a regular kind of CRUD-like system with a regular RDBMS and just kind of load and store the thing over and over just in a plain SQL database. But you can also run it as an event-sourced entity. And in this case, your algebra instance would be a persistent entity. So if you do Aecor persistence, for example, this would be your persistent actor. Calling a method would mean issuing a comment to an entity. Return value would be some kind of comment result. So when comment has succeeded, we get this result in the effect. But something is missing. And in particular, we're doing event sourcing, right? But where are the events? I can see them here, and I think you too. So where do they go? Aecor makes it all work under the effect type, this I thing. So this thing handles all the infrastructure, which events happen to be in this case. So as you might think, this has to be a very special effect, and we'll see that in a minute. So our usual letter F that we use in this case is isn't used here for a reason, because I is a kind of special effect. By the way, this underlying complexity of this effect is another reason why Aecor relies heavily on this dark undead magic of final tagless. When you use Aecor runtime to deploy such entities, this behavior is interpreted into like 4 to 6 different effects. So imagine writing all of that manually, like how much boilerplate that would be. And I'm not even talking about testing, so you would have probably another effect for testing, some kind of state-like effect. So as an application developer, you just write this thing once and you don't care. Aecor just fits in all the effects it needs to perform various actions. Yeah, so Aecor is an undead-friendly kingdom, actually, very technologically advanced and good one, of course. Yeah, fighting for love and referential transparency. So let's take a look at how it's implemented. So to describe this kind of effects, which I call command handler effects. So what we are describing inside those verbs are command handlers. So like this let's call it command handler effect. There are several type classes in Aecor that allow to describe such kind of effects. You can mix and match them. So if you take all of them, you would get something like this monad action lift reject. So what does it give us? So first of all, it has 5 type parameters. I is the kind of the effect we are trying to describe. F is a more regular, like usual I/O-like effect for various asynchronous things, for example. S is the internal state. E is type of events, and R is rejections. So we'll talk about them in a second. So this thing extends monad. What does it mean? We can compose our command handlers monadically, like through flat maps. So we can chain them together in a monadic way. This is a really powerful thing. Next, let's go part by part. So action thing is kind of the core, the essence. It allows us to read the current state of the entity, which has type S. It allows us to append events to the journal, or like we can say emit events. Events are of type E. And there is a less commonly used combinator reset, which is basically if you appended some events, you can kind of roll back. You can say, no, I actually, at current point in time, I understand that I don't want to append these things. So looking at this thing, you might probably think that you can't use future with this thing, because future would already be running, and you might have written something to the journal. You can't like erase it. Reject thing. So when a command comes to the entity, some commands might be invalid, and if a command is invalid, you reject it with some kind of message of type R. So this is like monad error, just a typed error. And the lift part allows you to embed a value in effect F into a more complex effect I. So we get our simple I/O-like thing, and we can embed it into more complex effects so that we can chain it with other command handlers. Let's see how we would write an interpreter for such thing. So we have our booking algebra. Oops, it was not the right button to click. Okay, I guess I don't have a pointer. Here it is. So we have our booking behavior extended, so we're writing this interpreter. What does it have? First of all, we still have 2 polymorphic effects, F and I, and we ask for a clock. So we would need access to current time. In functional programming, this is a side effect. So this is a side effect. We need an effect type to handle that, and we ask our instance of our type class to work with command handlers. So it would use the same I and F effects to run some state, use some events, and issue some rejections when commands are invalid. So now we can write our command handlers. I'll just show one, but others are written in a similar fashion. So first of all, we import our DSL, this instance of our huge type class. We import all the methods so that we can have a nicer syntax. Then we'll write a small helper to get current time in our command handler effect I. So how would it look? First, we call our clock, get the current time in the effect F, and then we lift it to our effect I, and just map the long to the instant. By the way, why do we do that? Let's roll back. So why would we need this separate effect F? The answer is because we don't need an event-sourced clock. So this I thing, as you remember, is a very special effect. It has a lot of functionality, and we don't need to have like a journal writing events for a clock or stuff like that. We want a simple like I/O-like clock. So that's why we need the second effect. Let's get back to our comment handler. So now we have our current time in the effect I, and we can write the expiration handler. So what is an expiration handler? When a booking was not paid for some extended time period, we want to expire it. So we send this comment to our entity, and it will check its state that it's really ready to be expired. And depending on that, it will perform some action. So this is a huge for comprehension. We can do that because I is a monad, as I said. So we can do flat maps. So we get our current time. Then we read the state of our entity. Since the state is an option, so the option represents the fact that entity might not be initialized by this time. So if this comment was sent to some entity with a not existing ID, then it means that entity was not, like the booking was not yet placed. So we cannot, there is no state, there is no this such booking, we just, in case there is no state, we just reply booking not found, booking does not exist. But if it exists, we match on the status, and depending on the status, we either, so if the booking is confirmed and it's time for it to expire, we append the event, the comment succeeded. In all other cases, we either reject the comment, or if booking is already expired, this is kind of not an error, but we also don't need to issue, to emit any events because booking is already expired. So we just ignore it. Ignore is just a unit, just basically I of unit, so just a shortcut. So that's kind of it, how you write comment handlers with this Aecor DSL. Any questions on this particular slide or previous ones? Because there's a lot of code. And read? Read is a method from monad action type class which allows you to get current state of the entity. So basically you can think of read as a recover on a persistent actor, but just semantically. So you kind of fold all your events into state and you get it under the effect I. But under the hood in the runtime, this might already be the actor might be alive, so in this case you just get a message back immediately. Any other questions? Okay, good. So this is not everything. With regard to behaviors, Aecor has also some really nice features, which I thought I wouldn't have time to talk about them, but I actually have, so I'll just speak a little bit. So first of all, Aecor is really explicit about separating identity and behavior. What does it mean? So it's again the same story of separating the essence of your business domain logic from all the infrastructure concerns. And if we think a little bit deeper about how our behavior works, we usually don't require identifiers. Identifiers don't take part into handling comments. They usually serve the sole purpose of locating, finding the proper instance, and that's it. So if we take a look at the algebra we have, let me scroll back. Yeah, so there are no identifiers. So this, for example, this same expire thing, it doesn't have any parameters. So the instance of this thing would already have, when it's created in runtime, it would already have some kind of identifier. The routing would already happen by that time. And we don't need this identifier to write our logic. So that's why this expire thing, it doesn't have any kind of IDs. So Aecor allows to do this in a very nice composable way so that you don't pollute your business logic with identifiers. Next thing. Yeah, so the same thing about metadata, various timestamps, correlation IDs, and things like that. Again, there is a really simple but really powerful composable mechanism to put metadata, like append it to your events at some later stage when you're at the infrastructure layer, not in the main behavior layer. So with the traditional frameworks and libraries, these things just don't work. You just have to put everything, kind of stuff it in. Here, it's a kind of composable. And since your behaviors are in final tagless, you can do natural transformations easily. This allows for really cool stuff. For example, you can have put a timeout on your behavior with just several lines of code, and this natural transformation would work for any behavior. It would just fail the action after some timeout. So some really powerful stuff is available. And if you want to take a closer look, again, you can follow this link. There is an extensive series of posts that you can explore. Yeah, and all of that is done in a purely functional way. There is Aecor cluster under the hood, but it's hidden from the end user, so you never face any Aecor stuff in your daily work, so it just works silently under the hood. It doesn't do side effects. Everything is suspended when it has to. So 100% purely functional experience for those who want it. And that's it for today. Thank you very much. Hope you have some questions.